Okay, so we're on to 4.1.5. We are determining the equation of the tangent DE. Right, let's first just fill in some things quickly over here. We found this angle, which we said was 36, 87 degrees. 87 degrees. I just want that on my picture, and then I'm going to erase some of the things above or below rather. So we need to determine the equation of the tangent, right? So what do you know about the tangent? About your tangent, your tangent is 90 degrees perpendicular to the radius. We know that from our Euclidean geometry, right? Let's just say that again quickly. We know that the tangent and the radius form a 90 degrees. Okay. We know that just by definition of a tangent. Great. Then we also know that when you have a line, let's say for instance this line that we have, and we have a perpendicular line, we know the relationship between the gradients. The relationship between the gradients is this: if you multiply the two gradients together, the product of your gradients will equal to -1. Or we could say the same thing. We could say the gradient of the perpendicular line is equal to the negative reciprocal. That just means you change the sign and you flip it, right? So I think when we found the gradient of AD, our answer was 3 over 4. Okay, I think it was 3 over 4. So now the gradient of DE, M DE, which is the perpendicular line, it's the negative reciprocal. So change the sign. It was positive, now it's negative, and flip it. So the 4 is on top, the 3 is at the bottom. Okay, great. That tangent that we have there is a straight line. The equation of a tangent, or the equation of a straight line, is y equals mx plus c. All right, we've already got m. We spoke about that in a second ago. We still need to find c. Right. So let's rewrite this with m in place. So y is equal to minus 4 over 3x plus c. Okay, this equation over here has how many unknowns? One unknown, right? C is the only unknown. Y and x, they are variables. If you have one unknown, we know we need one coordinate. So let's go look for a coordinate that is on the line that we are trying to find, right? We are trying to find this line. The coordinate that's on that line is D. So we are going to substitute the -5 -1 into this equation over there. The -5 -1, this we need to substitute into our equation. So y is going to be a -1, right, is equal to -4. The x is going to be the -5, get substituted in there. All of this is divided by the 3 plus c. So we need to solve for c. This over here, we're going to move over, we'll subtract on both sides. So my left hand side is going to be a -1. The negative and the negative over here, right? This negative multiplies with this negative. It's going to give me a positive, right? So when I get rid of it, I'm going to subtract. 4 times 5 is going to give me 20, and that's going to divide by 3, all equals to c. Right, so that you're going to go put into your calculator. I'm going to do this. I'm going to say 1 is the same as 3 divided by 3. So my c value is -23 over 3. Right, and let's go back and write our equation. So it's going to be y equals to -4 over 3x minus 23 over 3. Great. So that is our equation of our tangent. Let's just discuss what we spoke about quickly. So what did we actually do in this question? All right. We know that this is 90 degrees. All right? Because it's a 90 degrees, what we then know is the gradient of this line, which we found earlier, and the gradient of this line. The gradient of the perpendicular line is equal to the negative reciprocal. So you take the gradient of AD, right, and you change the sign, you flip it around, that gives you the gradient of DE. Okay, so that's the first things that we did. Once you had that gradient, you substituted it into y equals mx plus c. All right, I wanted to circle that, not erase it. Y equals mx plus c. And then we substituted our m value. leaving us only with one unknown. If you have one unknown, you need one coordinate. So we substitute our one coordinate that touches our line into our equation and simplified, and that gave us our general equation over there. Great.